Hello, everybody. It's Mr. Joseph. Today, we're going to talk about this baseball task. I'm going to give you some few hints and guide you along your way. So, if we look at this first question, we see that we have a baseball field with some points, and it tells you specifically what everything represents. So, we have a left and right pole, we have home plate, first base, second base, third base, and we have the semicircle that kind of gives you the outfield. So we have this nice baseball field, and the one thing that we see in bold is the fact that 1 unit on this coordinates plane represents 10 feet. So really quickly, I'm going to show you what 1 unit represents. So from here to here, so from 5 to 6, that represents 10 feet. So we're going to have a lot of discussion about how to deal with this 10 feet and when we convert and stuff like that. But I just want you to give that visual that 1 unit equals 10 feet. So I'll erase that for now. But I'm glad you have that visual. So let's go ahead and let's get started with the first question. The first question says the entire field minus the diamond HFST will need to be covered in grass. If the price of sod is 79 cents per square foot, how much will it cost to cover this area? So when you're looking at this, the hint says if one square unit is 10 by 10, how many square feet is that? So we'll talk more about that. So the first thing that you got to do is you got to make sure that when you're finding the area, you're going to exclude this square. So you're going to exclude this square. My hint to you, or my advice when approaching this question is I would find the area of this triangle. And if you find the area of this triangle, just remember that you're probably going to have to find the area of the square as well because you're going to have to subtract it. So let's just talk about units for a second. So from my experience, I'll just do the first area and I'll let you do the rest. So area of a triangle is 1/2 times base times height. So what a lot of students did, they looked at HR and they were like, okay, cool, that's 30 units. And then they looked at HL and that was 30 units. So a lot of people did is we did 1/2 times 30 times 30 equals 1/2 times 900, which equals 450. And then they took the 450 and they remembered that this is in units and they multiplied by 10 and they got 4,500, and then they multiply this by 79 cents. So actually, before we multiply by 79 cents, we probably should subtract the square. But a lot of students would do this. And I want to show you, first of all, I want to show you a mistake that was made here. So first thing that we should have done a little better is write the actual units. You should write 30 units times 30 units. I think what we forget is we forget that 30 units, if we converted this first into feet, that this would be 300 feet. And the same thing would apply over here. And as you can see, we are totally going to get a different number, right? We are going to get 90,000. Still got to multiply by half. And the area equals 45,000. Which is similar to 4,500. So what was the mistake that was done in this problem over here? So the mistake that was done in this problem over here had to do with the labeling. Because if you think about this 450 real quick, I'm going to erase this. I'm going to write 450 again. You should have wrote 450 square units. And if you were going to convert 450 square units into square feet, you need to say that um, 10 feet over 1 unit times 10 feet over 1 unit. And as you can see now on the bottom, you will get 100 square feet over 1 square unit. And this will cross out, and you would get the correct answer that we got earlier. So just an FYI, if I were you, to be real, I would just always take the units and convert them to feet right away, so I wouldn't have to remember this. But if you want to do it this way, just remember that when you're taking 2, you're going to have to write it twice because we are talking about area and we were multiplying units twice. So just keep that in mind, whichever way that you proceed. Another question students asked me was, how do I deal with this lovely square over here? Sorry. How do I deal with this circle over here? So my hint to you is that you need to find the midpoint. Find the midpoint. Maybe this is the midpoint. I don't know. You can check. Find the midpoint and then find the distance of the radius. So that's all I'm going to say for that. Okay? Now we're going to move on to question 2. So question 2 is talking about volume. So if you remember anything about the conversation we just had, something that you should be skeptical about is the fact that the price of the dirt is $34.75 per cubic yard. So just remember, the problem said that 1 unit equals 10 feet. So somehow we're going to have to go from units to feet to yards. So just keep that in your head. Am I going to go ahead and turn all of the units into feet before I start doing math? Or am I going to do all the math and then convert it after? You have to decide how to approach this. One thing I'll help you on, though, is I'll help you with the 4 inches. So 4 inches, if you want to convert this into feet, remember, you can always write that 1 foot is 12 inches, and that inches crosses out, and you get 4 over 12 feet. So that would be the depth of the dirt that you're going to fill. So that's like dimensional analysis. If you ever did chemistry, you probably saw something like this in terms of the units. So 2 reminders for this problem is I want you to think about how does it being cubic yards has an effect in comparison to being square yards. And second thing is, do I understand how to convert like 4 inches into feet? Even though I did that for you, just make sure that you understand that. And then the most hated question of them all is question 3. So one thing I'll say about question 3 is I think the intention was good, but it turned out a little bit more confusing than it should have. So you have $30,000 worth of sod, and you want to fill up the outside of this baseball field. So one thing that we did as a team is we gave you 0, 0 to 35, 0, 0, 0 to 0, 25. And I think something that was confusing about that is all we're trying to do in this problem is we're trying to fill up the area over here. So I want you to figure out how much it's going to cost to fill all this up. So that is one of the main intentions. And the way that the question is written makes it seem like all you can do is place it in this area right here. So I think we said the units once again just to show you that it was on the outside. But one thing that you're going to discover when you find out how much it costs to do this area I just highlighted in yellow, you're going to find out that it's less than $30,000. It's going to be around $25,675. So you still have some money left over. So what you're in charge of doing is we're going to remove this theoretical blue line, and you're just going to keep extending it. So maybe you might want to fill up this whole square. Maybe you might want to fill up half of it. Wherever you end up filling it, I want you to do the math and see how close you can get to 30,000. So do you want to extend this triangle here? Do you want to make a square? If I fill this square and this square, would that be too much? I want you to use your discretion on how you are going to use the extra money to fill out outside of the baseball field. So don't feel like you're restricted to only the yellow parts. So that was a little confusing. Sorry. It wasn't meant to be that way. I promise next year, if you come to my classroom and see this problem, we will definitely type this up a little differently. Our next question is number 4. So number 4 is talking about fencing. So just remember with fencing, you have to think about circumference for this circle. Remember, you need to think about circumference, which is 2 pi r. But remember, this is for a whole circle. So that how does this not being a whole circle, how does that change the formula? And just remember that you're not focused on the inside lines. You are only focused on the outside. Okay? I don't think too many people had problems with this one, but just want to do a quick rehash on that. All right, last but not least is question number 5. This question, once again, is a long paragraph. This question really tests segment partition. That's one thing that I wanted to focus on in this question, and just your ability to follow instructions. So you'll see right here, I said 10 feet deep, but on your paper, it should say 10 feet wide. Okay, so that was fixed in your copy. So what do we try to do here? So pretty much we're trying to make dugouts. And if you know anything about dugouts, they're normally like outside the field. So they'll be like somewhere. Let's see if this thing will work. Let's see, it's acting up a little bit. Let's see right now. Let's see, why can't I write on this? Okay, so dugouts are like somewhere right here and somewhere right here. I didn't do the math, but the dugouts are where the players wait, and they're normally outside of the field, and they're normally that wide. They're not that big, okay? So that's pretty much what we're trying to do, is we're trying to design some dugouts, and we had some really specific instructions how to do that. So the first step involved doing segment partition, and you'll see in the question, it'll say from, I believe, from first base to home base. So if we see this first thing, the left edge must be 2/3 of the way from first base to home plate. It's really specific in the direction. Must be 2/3 of the way from first to home. So when I count here, I'm gonna see 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I look at this and I think of 2/3, I know I need to split it up into thirds. And I know the point that I want is this one right here, because that point is 2/3. But before I did that, I just split it up into threes, as you can see. But the first instructions was that we wanted to do 2/3 of the way from home base, and that was the left edge of our home plate. And then the right one says it must be 1/7 of the way from first base to right field. So then you're looking from, let's use a different color. You're looking from here to here, that we must be 1/7. So if I look at this number is 14. I look at this, that's 35. I ask myself, how far away is 35 from 14? That is 21 units. And if I'm trying to find 1/7, that means I want to divide this into 7 parts. So that means every 3 units. So I'm going to count 1, 2, 3. So I know that my other point, and I'm going to put a X above it, should be right there. So far I have found the part of the question. So something confusing is you think the dugouts are actually on the field, but it's not. And you're going to see the further instructions that tell you that that's not true. So if you keep reading here, it says that the dugout must be 40 feet back from the baseline and must be 10 feet wide. So when I look at my picture, I need to be 40 feet away from the baseline. So if you think about what 40 feet represents in terms of the units, that means 4 units. So I'm going to take that star and I'm going to move it down right here. I'm going to take this star and I'm going to move it down right here. So those are the points where my dugouts are. And then the question says it needs to be 10 feet wide. And if I do wide, I just make my line go down because we know that 1 unit equals 10 feet. So we see that it's 10 feet wide. So that was kind of the intention with that problem. I think I might have done too much for you, but you have the other one to deal with. So that was the idea behind this. So this task is a really great task. My goal in making this test for you is to make something like this that connects everything, but it's less confusing in the wording. I'm going to make sure to make the wording clear, make it a scenario that we're all familiar with. But I hope you can appreciate how we took something in real life and we kind of designed it and kind of try to use some real life applications. That's all I have for you. Thank you.